this innovation center is really the first effort we've seen anywhere in any government to cross all those boundaries at the same time and try to bring people together to innovate on the tools, the technologies, and the ideas behind what we might do in the future.
And I think that having that all together in, one location, one center is something that's never happened before in Spectrum.
Welcome to Spectrum Matters, a podcast presented by SpectrumX, the U.S. National Science Foundation's Spectrum Innovation Center.
Welcome, everyone, to episode 2 of our NSF SpectrumX podcast, Spectrum Matters. And today we're talking about research, essentially, looking at the various efforts that are being put forward by the SpectrumX Innovation Center at Notre Dame. And with us are two people who know more about it than probably anybody, and they should. The Director of Research, Dr. Randall Berry, who is also a professor of electrical and computer engineering at Northwestern University, and his deputy director, Frank Lind, who is a research engineer at the MIT Haystack Observatory in Massachusetts. Great conversation. Here it is. Enjoy, and we'll see you on the flip-flop. Gentlemen, thanks for joining us. This is, I'm really looking forward to this. Hope you're both doing well. Frank?
Yeah, thank you very much.
Great. First of all, let's find out, I think our viewers, and I know myself, would like to learn a little bit more about you guys. You're involved with the research component at the SpectrumX Innovation Center at Notre Dame. How did you get where you are today? Let's start with you, Randy. Tell us a little bit about the young up-and-coming youth that got to electrical engineering and computer engineering and got to where they are today.
Sure. So how far back to go, right? Well, I guess I can say I got into, I went to college as a undecided major. I did not know what I wanted to do after high school. I often tell my, young kids that you don't have to know what you want to do. I decided I was interested in engineering, and I decided on electrical engineering primarily because I was really into music when I was a kid, and I liked my stereo. I liked listening to the radio, and I knew all that had something to do with electrical engineering. And and because of that, I think I found communications to be sort of one of the most interesting classes in the major. It was a class where you had sort of this combination of really elegant mathematical theory that was really applicable and could explain, how AM radio works, how FM radio works, and I really liked that combination of, nice theory and a tie to practice.
And you listened to radio when you were a kid, and that kind of got you going, right?
Yep, that's right.
Were you 12 years old, had that radio next to you under the pillow or something when you fell asleep?
Yep, that's right. Always listening to radio. And then, I guess in grad school, I got into, I wanted to do communications, and this was in the 90s. And, one of the big things that was happening at that time was wireless. So I remember, there were some of the first classes on like wireless communication were getting offered while I was at MIT for grad school, and these were it was driven by the growth, the explosive growth in 3G at that time. Qualcomm with CDMA was a new kid on the block that was making lots of waves, and that's sort of how I started. Found my research direction. And then after I joined Northwestern in the early 2000s, sort of coupled with all of that growth in wireless technologies, spectrum started to become an issue. And there was early discussions about how to rethink how spectrum is allocated, how to share spectrum, there was these ideas of cognitive radio that became kind of ingrained at that time, as you using new devices that could sense and think and figure out where to communicate, and so that's sort of how I ended up in this space.
Great. We'll talk a little bit more about that. It's kind of an advanced portion to this. I want to turn to Frank. Frank, tell us where you started, and were you listening to radio when you were a kid, or were you building the crystal sets?
So here's the ironic thing. I wanted nothing to do with radio when I was young. So my family, I ended up growing up with my grandparents outside Seattle, just north of the city. And my grandfather had been in World War II. He'd actually gone to the MIT radiation lab and learned about radar. And he came out to the Pacific Northwest to a place called Whidbey Island Naval Air Station and was teaching soldiers who were going to the Pacific Theater about how to use radar with their ships. And we've got some nice photos from him doing that, in his uniform and stuff. And, he's an officer. And at the end of the day, eventually the family ended up moving back after the war to Seattle. And so my family grew up in the Northwest. And I was very steadfastly interested in space and physics, in computers. I was there when the computers were new. So I think of the movie War Games, right? Those are the kinds of crowds of people that that I might have been hanging out with as a young man, and or a youth. And
you were Matthew Broderick.
I was, well, not quite. I'm not. I don't have the hair like Matthew does, but but. So anyway, the net result was that I was very into computers and physics. So I set out to learn about that stuff. And I went to University of Washington, did a couple undergraduate degrees, went on to grad school. I ended up having to find someone to work with, and different faculty had some money, and I went to meet them. And one of the gentlemen, he's a brilliant optical physicist, and he showed me his lab. And the only thing I was really good at laboratory work and technical things. And then, the other guy, honestly, he handed me some papers on plasma physics and on radio. He was an electrical engineer. I was actually over in geophysics, and he was like, and there's all this stuff I like to do with radar, and I want to build a radar that doesn't have any transmitter. Okay, and that's not quite what happened, but it was actually like, how do you clap with one hand, right? So that slopped me into radar. And then I ended up at the end of that little foray of my career, the start of it, I ended up with opportunities because I'd done some work that was pretty impressive to a lot of people. And MIT made me some good offers and treated me pretty well across the board. And I had a couple job offers from different parts of the institute. And I picked the one that was the more academic research. It wasn't, maybe as well paying, but it was a lot more freedom. And I became the person who does a lot of radar at first, and very big radars and all kinds of them. And then that led me to radio astronomy because the observatory does that. And I branched out into whole kinds of areas of space science and leadership and running projects and programs. So it's not what a typical professor does. We've been doing research at Haystack, kind of it's full time for people, challenging in some of the economic times, but overall, there's a lot of different projects and programs we get to work on. And so that's been kind of my path. And I ended up at a certain point giving lectures on radar at MIT campus to a bunch of the Radio Society folks. And, I have to say that felt like real closure with my grandfather's life there. And it's interesting because I ended up in a thing that was great for me, and in space science and in radio. And, that led me then to get pulled into SpectrumX. Some of the people involved knew about us, had worked with us in other projects. And there was a need for some of the technical depth that I can bring to programs, as well as the managerial skill. And so, I got to work with Randy to do some really exciting structuring of the center research, and to push people to do their best and to really produce wonderful stuff. And I have been absolutely astounded how wonderful our team across the SpectrumX Innovation Center has been, and the amount of work that every time I go to a meeting and I see how much people have accomplished, I'm just kind of in awe of how effective a small group of people can be with a little bit of resource. So
that's probably a great place to segue into what the Innovation Center is doing right now, and where, as the director and deputy director, you've sort of seen areas that need to be addressed and what actions have been taken. radio spectrum, as most everybody should know, is a finite resource. And tell me if I'm wrong, but there are basically, you have to as need increases and the number of users increase and the amount of space and data that everybody is craving, you need to figure out a way to maximize what exists. Tell us, is that involves refining the tools we already have and finding new tools? Is that right, Randy?
Yes. I mean, I think you summarized it. I would say, and step back a bit. When you say maximize, even there is a ton of different users of radio spectrum, and you're trying to balance all of their use. Well, some are growing, some are not. Some may be growing in the future. So it's a very challenging problem, and those uses include things like Frank mentioned, like radar. They include radio astronomy. They include, our wireless devices, cellular, Wi-Fi, satellites now, right? So just all kinds of different uses, all competing for this finite resource. And to your question, yes, I mean, it's refining what we're doing, trying to find new ways of using the spectrum, and those new ways can be both technical and they can also involve new policies, new that's a big part of this as well. It's very multidisciplinary.
And so this is one of the pieces of swag that and that's pretty much sums it up, doesn't it?
Yes.
So Randy, this idea of coexistence is really at the heart of spectrum management. Frank, underneath all of the competing wants and needs, what is it exactly that we are managing?
Yeah. So underneath it, this is about light. It's about our environment. We live in a world that's full of light. All right. And some of it you see with your eyes. And ultimately we have found that there's a lot of utility to a lot of the colors of light we don't see. Right. There's different ways of using them, whether it's to sense things in our environment with radar or to communicate with each other using our cell phones, right? So there's all kinds of technologies that have developed out of our ability to manipulate these types of light that we don't see with our eyes. And we use tools to do that. Sometimes they're called antennas and radios, right? And when you start getting a lot of human beings doing anything, often you need to have some way of guiding and coordinating that so people can work together. You might want to shine a bright light on your neighbor, right? They might not like that. So you might have to compromise on what that light looks like. Or you might want a big bright Christmas display that, happens to be at a wavelength that nobody else sees. And it might be so powerful it would hurt people that got near it. And we can't really have that happening, right? So I think of it as, the management of radio is about fancy light decorating. Okay. It's really about us working together to try to make, almost an aesthetically pleasing environment, I'd say, but it's really more for us about the utility, right? It's about getting value for society out of our use of radio, about enabling scientific discoveries that are possible by listening to incredibly weak signals from all over the universe. All right. And at the same time, we have people who want to innovate and do new things and sell products and achieve commercial, and economic success, the American dream, right? And so they need to be enabled to do this too, even in an environment where, their competitors might go, well, we'd rather they not actually get to do that, right? So there's creating a balance in society of how we use this environment and also how we protect, aspects of it that are critically important for some missions and abilities we have to sense the environment. So there's this wonderful balance of science, technology, defense, commercial that the center brings. And SpectrumX is the first thing. This innovation center is really the first effort we've seen anywhere in any government to cross all those boundaries at the same time and try to bring people together to innovate on the tools, the technologies, and the ideas behind what we might do in the future.
So coexistence becomes a question of sharing the same ball field, if you will, without somebody's football getting onto the baseball diamond. Is that right? Is that a useful way to think about this as the real challenge?
The sports analogy is a really good one. You have a ball field, right? But the ball field might be used for soccer. It might be used for football. Who knows? You might play baseball on part of it, right? And if you do all those sports all at the same time, they're going to get on top of each other and nobody's going to have a good time, right? On the other hand, one thing you can do is schedule things and you can schedule the use. Another thing is you might have two fields and say football's on one of them and soccer's on the other, right? So that's a great analogy for how you coordinate radio. You figure out how to split it up and share it and coordinate, and at the end of the day, you get something that functions way better for everyone.
Frank, with so many stakeholders bringing their different priorities to SpectrumX, is the Innovation Center meant to serve as some sort of technical arbiter?
Yeah, I don't know that we're the arbiters. We're a source of independent thought and information, right?
Yeah.
Ultimately, the government has agencies that make these choices. Okay, having them make choices based on the best facts, ideas, approaches. Well, that's something that we're doing, right? I mean, Randy, you have your perspective on this because Randy's research approaches a lot more of this side than I do. I often deal with the technical nuts and bolts. So,
Randy, you must have some perspective on this.
Sure.
Weigh in?
Sure, definitely. First of all, I'd agree with Frank. I mean, we are not the arbiters, but I think we are a source of independent truth. That's not beholden to a commercial or non-commercial interest in a particular use of the spectrum. And if you look how a lot of policy type decisions get made, there's usually a call for comments where people submit comments. And if you look at who submits comments, it's usually someone who wants the decision to go one way or the other way, and their comments are very much skewed and in line with their view of how that outcome should be. And I think having an academic institution like SpectrumX that's neutral, that can look at both sides and say, based on our expertise, here's how we feel about these issues, has a lot of value in this.
So let's turn now, if you would, to some of the priorities that you've seen, action items, if you will, and what you guys are doing. What are the? I think you have like 3 different areas that you guys are talking about. You have seed projects. You have the RCs, the research communities, right? And then you have your flagship projects. I have that right, Randy? Tell us a little bit about each of those.
Sure. So we've structured the research in SpectrumX into those 3 buckets. I'll let Frank say more in a second about the flagship. So he's primarily the driver between our 2 flagship projects. These are designed to be, large projects that bring together all of the different expertise in the center in sort of focused efforts. Seed projects are something that we compete annually. So we have a call for proposals within the team. These are smaller projects that are intended to seed new ideas. Some of these in the past have been things that have led into the flagship project. Some of them have led into other proposals getting sent out from the center. And so it's a way to support new ideas that and then finally the research communities, as you mentioned, these are more of a way to convene people within the center that have common interests. So people that are interested, say, in AI and ML applied to spectrum can all show up for a monthly meeting and talk about issues related to that. Artificial intelligence, machine learning, which are hot topics.
And the flagship projects, we ended up at a certain point in the center wanting to create focused efforts. This really happened after kind of the interpersonal team building happened. We had to get to know each other, and you start a new project with all these universities and faculty and staff, and it takes a while to get to the point you can trust people, you can work together, you understand who's good at what. And we pivoted in the center, the research, to put a huge amount of kind of the effort into 2 flagship project areas. One of them's focused very squarely on kind of next generation wireless technology. There's a band that's going to be used for what will become 6G worldwide, and we're very interested in both how that can be used and the potential impacts it might have on existing systems like radio telescopes. And there's also a lot of government satellite communications that happens in these bands. And so we wanted to focus very strongly on innovating in technology and innovating in measurement, push those capabilities into our center and our members, and then get their leverage to provide some approaches and solve some problems that maybe even that people haven't thought about yet. Okay. And at the same time, we were bringing in some of our government partners, and having them involved in the discussions, and our students would learn from them. They would get to go out in the field and do some experiments, and that's turned out really, really, really well for us. The other flagship project is on coexistence with mega constellations. So, this is not just about Starlink, although they're the first and the biggest and the mostest kind of, but this revolution in launch capacity and the ability to put things in space inexpensively has only just begun. And we are seeing already a absolute proliferation of satellites. And every satellite has a radio. Some of them use radios for communications, often some of the most advanced radios anybody's building. All right. And yet they're up very high and visible to everyone. All right. Not just in the United States, but globally often, or, half the globe can see some of these satellites at one time. And so the coexistence problem in space is growing, and the desire to use more and more spectrum is growing. And so balancing these things with other priorities, like being able to predict the weather using, very sensitive radio sensors that we have in orbit, having things on the ground that, your cell phone in a remote location, you might like to be able to communicate. And, things like Starlink let you do that. And they are providing enough value that people are, really investing in this, and that, it's making money. And so there's a balance that needs to happen, though, with this is happening so fast. We wanted an area to focus on some of the potential scientific impacts.
Well, you're protecting a resource that is essential to scientific exploration.
Mm-hmm.
Well, and often to our technologies. We use radio and scientific radio for a surprising number of important things in our society. GPS, for example, synchronizing our clocks globally. There's all kinds of stuff that's hidden in the weeds that you may never even have heard of that's done with radio. And yet our society, our technology often rests soundly on it. And being deprived of it, would we work around it? Well, you make do with whatever you have to in life, right? But on the other hand, we do enjoy the fruits of a really amazing technological civilization, and sustaining that, and being able to expand those capabilities and new abilities, new businesses, new technologies. That takes some thought. It takes thinking ahead. And spectrum, for a long time, spectrum management has been kind of a 19th century treaty process. It came out of the very beginnings of radio, where you had steamships and bone china, and you would go to Europe to meet for 2 weeks. And we're now in a absolutely hyper-competitive AI-driven world that is coming headlong into the desire not just to share radio, but to dynamically reconfigure our electromagnetic environment in response to human needs. But at the same time, we want to be able to, configure to discover things in the universe, right? Often those things are at odds, and putting the foundation in place for that revolution to happen, we're just at the beginnings of it. And that's what's really exciting about SpectrumX, is all these really earnest, intelligent people working together to identify and solve problems, many of which, people have maybe even known about, but not been able to make progress. We've been very, very agile, and we do things very quick. And so that's one of the really exciting things, this pace of innovation. It's a little hard to maintain, and you lose your breath sometimes.
But the direction that you take is reliant upon a collaboration beyond just the people who are at the center at Notre Dame. We're talking about the universities, the experts who are participating, the external advisory board. I think there's another advisory board, the CAB.
The Collaboration Advisory Board, yes.
Okay, and so everybody gets together and they figure out what these priorities are and where to go. So it's not a case of this small little group, like like I maybe alluded to it being arbiters. We're going to look at this and that. Everybody kind of gets together and there's a consensus that needs to be addressed. This is a big problem. We need to talk about that. Tell us what, Randy, in the short time that we have left, tell us about the areas and specifically the projects that you are most excited about. You probably don't have enough time to discuss them all, knowing how y'all operate.
Oh boy. So I mean, I think Frank was a little. I think that the flagships have been great to see. I think it's we have done a lot in a very short time. I think they are. They also span across the center, as we alluded to. So for example, our first flagship involves everything from building hardware to going out and using that hardware to take measurements, to having a system for the data after you do those measurements that you can use to apply advanced algorithms on, to thinking about how all of this shapes future policy. And I think that having that all together in one location, one center is something that's never happened before in Spectrum.
And of course, everybody sharing cuts down on the duplication of effort.
Yep.
Everybody going off in their own direction. Now you're kind of funneling it in the same. You're collaborating essentially to the same goal. I know we had Anya Forey on in the last episode with Nick Lanneman, of course, is the center director, and they talked a lot about the collaboration with the students and getting them involved, and
Mm-hmm.
I know they were part of that flagship one very, very strongly with citizen science also, and the REUs, the research experience for undergraduates.
Yep.
And these are all things that are, cross programs, if you will. They develop the workforce for the future, but yet you're seeing some real useful research out of that.
Yeah, well, one of the things we did in the flagship was build it around student experiences. And this is really more the advanced undergraduate, the early graduate students. A lot of people spend a lot of time at their computers and their desks, and that's just a teeny part of the world. You've got to actually get out and go do things. And radio, we need knowledge that comes from measurement, and the measurements come in the real world and all kinds of environments, sometimes very remote, very difficult. We do a lot of that at Haystack Observatory. We don't just work at the observatory. We go all over the world, the Arctic, the Antarctic, the deserts of Australia, South America. We do things in environments that are really hard to deal with because that's where the science takes us. Okay. And so I wanted those experiences to be brought to our students. I wanted them engaged, involved, out in the real world, dealing with things that don't work always and that are imperfect and are hard to understand sometimes. But when you do it and you actually dig into the data that are collected and understand it, you get breakthroughs. And I even saw this with a grad student who's working with me at MIT right now. He was taking real world data, looking at it for Starlink, and he was not understanding it. And he was almost at the point of despair that he was going to understand it. And I knew from experience that was right before the breakthrough happens. All right. And in fact, that's what happened is he understood stuff 2 weeks later and was able to predict and model it and brought about kind of a very big advance in us knowing what was going on. And that was great to see. Okay. So it's really about the kids. It's about the people. It's about making sure our country has people in the future who know about radar, about radio, about spectrum, about wireless, who, some of those kids will go off and start the next company. There's people out there who are going to be these next innovators, but they have to have projects and experiences on the way to get them capable of doing those things. And there's an incredible group of people across SpectrumX. I mean, I never would have met Randy without SpectrumX and worked with him. Honestly, we were in two completely different worlds, even though we were adjacent to each other in interests. All right. So that's been one of the wonderful things about SpectrumX is we have absolutely everyone who could be or wants to be interested in Spectrum. We've got ties into now a lot of corporations that have been involved. We've got external advisors who come in and help us understand kind of the bigger political environment and what is important. You alluded to, we're not just deciding, we are responding often. Our flagship research was a response to national interests and priorities, and we looked at what the interesting problems were. We looked at our talents, right? You've got to have things people want to work on. It's got to be interesting. It's got to be exciting, or why would they want to be involved? Okay. I heard a comment at one point somebody made is that if you're doing radio, you're stuck in the 20th century or whatever. Well, that's only if you're doing 20th century radio. All right. We can do 22nd century radio. Let's be ahead of things for once. And let's revolutionize how we do these things and what we can do. And that's really where the excitement actually is, and along the ways, we'll have some fun.
What Frank was saying, and what you mentioned earlier, that I think is also really important to highlight in a center like this is though we have these different areas in the center, like you mentioned, you spoke to Anya about education, and we're representing research. These are not stovepipes by any means. I think a lot of what happens in research is very valuable for education, and it's very valuable for collaboration. And that cross-fertilization is another great thing in a large center like this.
Yes, and to your point about stovepiping and siloing, it renders so much useless if people aren't talking this way to one another, and rightfully so, I guess. SpectrumX can lay claim to the world's largest academic hub for all things radio.
Easily.
Absolutely.
All right. On that note, guys, thank you so much. It's been a real pleasure. I think we'll be able to dive deeper into some other projects, some of the projects that you have there. I know there's one called Radio Hound, and just, good student explorations. And an upcoming episode is going to talk about management, spectrum management as a career, which a lot of people just fall into that today, and SpectrumX is making the effort to make that something that the future generation is going to want to pursue as a career, much to our benefit. So thanks a lot. Appreciate it. You guys take care and stay well.
All right. Thank you very much, Al.
A great conversation today with Dr. Randall Berry, who is the Director of Research for the NSF SpectrumX Innovation Center and Professor of Electrical and Computer Engineering at Northwestern University, and his Deputy Director of Research at SpectrumX, Frank Lind, who is an engineering researcher at the MIT Haystack Observatory in Massachusetts. Great conversation, setting us up for, I think, some future ones that'll be great about some of the specific projects that they've got going, some of the wonderful advancements that they've made, and we can dive deeper into those. In the meantime, thanks for watching. Stay well and take care. Be sure to check us out on our SpectrumX social media, like and subscribe wherever you can. And of course, be on the lookout for our next episode of Spectrum Matters. I'm your host, Al Feinberg, and we look forward to seeing you again on Spectrum Matters.